In 1941, London was under attack. The city was bombed by Germany almost every day, which injured Albert Alexander, a 43-year-old policeman. He received a large cut on his forehead from the falling debris of a building, but wasn't seriously injured. It wasn't until days later that the infection set in. Despite cleaning out the wound and religiously washing it, he developed a fever and abscesses on his face. One of his eyes was lost to the infection as it slowly spread throughout his body. Albert's condition came to the attention of Dr. Fleury, a researcher at Oxford, who had tested a new drug called penicillin on mice, but was fearful to do it in humans due to the unknown side effects. Once Dr. Fleury saw that Albert's state was terminal, he decided to use the antibiotic on him. On the 12th of February, 1941, 160 milligrams of penicillin was administered to Albert, the first dose ever administered to a human. Then a miracle occurred. His fever dropped, his appetite came back, and the wound, which had been oozing pus and blood, began to heal. However, Dr. Fleury only had enough of the wonder drug for 5 days. Even after extracting the drug out of Albert's urine and re-administering it, Britain's entire penicillin supply was used up on this single patient. Without the continuous treatment of penicillin, Albert's infection came back stronger than ever, and he died on March 15, 1941. So, how was this wonder drug developed? And how did researchers go from only extracting 5 doses of the drug in 1941 to producing billions of doses for D-Day by 1944? The idea of penicillin came much earlier than its discovery. In 1910, a cure for syphilis was found, which set off a race to find more magic bullets to fight against other types of bacteria. It was a chance event in 1928 which finally led to the discovery of penicillin. Alexander Fleming was talking to a colleague after a long vacation when he noticed something peculiar on his agar plate. There was an invading fungus on the plate where no bacteria would grow. He noticed his fungus had antibacterial effects on a large class of bacteria called gram-positives. But try as he might, Fleming could not isolate the penicillin as a therapeutic compound, and so it remained as a scientific curiosity for nearly 10 years until 1939. The researchers at Oxford were able to isolate penicillin from the fungus. It turns out this fungus was producing penicillin to kill the bacteria around it. After testing it successfully in mice, the researchers published their findings in 1940. In 1941, they tested their drug for the first time on the policeman Albert. Other patients after Albert received the drug to great clinical success. However, in 1940 and 1941, the UK was in the throes of World War II, and their pharmaceutical companies didn't have the bandwidth to start producing a new drug. That's when the Oxford team turned to the United States for help. The Oxford team arranged to come to the United States in July of 1941. The US government immediately saw the importance of penicillin, as hundreds of thousands of soldiers died from infections of battlefield wounds in World War I. When the United States was attacked at Pearl Harbor only 6 months after the Oxford team arrived in the United States, the production of penicillin came under the jurisdiction of the War Production Board. The board wasted no time. Over 39 separate drug companies were working on the problem, and the scientists made quick leaps in the production of the drug. First, they identified stronger strains of penicillin. They replaced the media they grew their bacteria in with corn steep liquor, a byproduct of cornstarch manufacturing, which turns out there's a lot of that in the Midwest. And finally, the biggest leap forward, deep tank fermentation. This involved putting the mold into a huge vat filled with corn steep liquor and then pumping sterile air through it. The air had to be sterile, as any amount of bacteria would contaminate the entire vat and cause the destruction of penicillin. Extraction of the drug was done at very low temperatures, as heat could destabilize the product. Meanwhile, the drug was tried in a variety of clinical scenarios and effective at treating streptococcal, staphylococcal, and gonococcal infections. Production continued to scale up as the government pumped more money into the development. Pfizer was one of the companies who used deep tank fermentation. They purchased an old ice factory in Brooklyn and turned it into the world's first penicillin factory. As more factories quickly came online, penicillin production jumped from near zero in 1942 to 21 billion units in 1943 to 1.6 trillion units in 1944, and finally 6.8 trillion units in 1945. Manufacturing sophistication had changed from 1-liter flasks with a 1% yield in 1941 to 10,000-gallon tanks with an 80 to 90% yield. As of March 15, 1945, all civilian restrictions on the sale of penicillin were removed, and it became commercially available. One of the members of the Oxford team said this about American manufacturers: "Too high a tribute cannot be paid to the enterprise and energy with which the American manufacturing firms tackled the large-scale production of the drug. Had it not been for their efforts, there would certainly not have been sufficient penicillin by D-Day in Normandy in 1944 to treat all severe casualties, both British and American." In the field, the results were astonishing. Gas gangrene, a highly lethal infection which killed 150 out of every 1,000 casualties in World War I, was now completely treatable with a recovery rate of 94%. Recovery from burns, which covered 1/5 of the body surface, was now 100%. Battlefield amputations to prevent infection, which were so common in previous wars, now became a thing of the past. Clearly, the drug saved hundreds of thousands of soldiers from infection and death. And for civilians, we are still reaping the benefits of penicillin today. Penicillin went from a scientific anomaly to a mainstay of treatment for infections in 15 years, from its discovery to its mass production. Today, when we struggle to come up with new classes of antibiotics to treat antibiotic-resistant bacteria, it would be wise to look at the international cooperation that led to the development of the most important drugs in humanity's history. Thank you for watching the video, and if you enjoyed this video, please comment below what other topics you'd like me to cover. Thank you.